All right, so we've basically covered all of the nice, easy scenarios as far as adding or subtracting vectors, whether it was just doing it with pictures or even once we threw the numbers in, we only really looked at if they're going the exact same direction, if they're going in opposite directions. We only looked at parallel vectors. Realistically speaking, that's going to happen very rarely. So what I want to talk about now is what to do if you're working with vectors that aren't going the exact same direction or exactly opposite directions. And so before we even get to adding or subtracting vectors that aren't going the exact same direction or the exact opposite directions, I just want to handle one vector in particular. So let's just take a look at what I'm going to call vector A. I'm going to give vector A a magnitude of 5. And now you can notice vector A is crooked. Vector A is not perfectly horizontal and it's not perfectly vertical. So what I'm going to do is I'm going to represent vector A's direction with an angle. Let's call it 30 degrees. And so that's one way that we could represent direction. We've already talked about you could use positive and negative, or you could use forwards, backwards, up, down, left, right, north, south, east, west. But you could also represent the direction mathematically with an angle to tell us exactly what angle from 0 vector A is located. What we're going to have to do with vectors like this, especially when we're working with 2 or more that are not going the same direction, is we're usually going to have to split these up into their x and y components. And so that's what I'm going to do with vector A. I'm going to take vector A and I'm going to find the vertical or y component of vector A. Think about your y-axis from algebra class. And I'm going to figure out the x component of A, the horizontal component. Again, thinking about the x-axis from algebra class. So it's just going to look something like this. This right here would be my x component of A. I'm going to call it AX. It's not its own separate vector, it's just a chunk of A. It's just the horizontal chunk. And I'm also going to write down the vertical component, or draw the vertical component of A. I'm going to call that AY. Again, it's not its own brand new vector, it's the y component of vector A. It's just telling me how tall A is, just as AX was telling me how long A is. And so those are my x and y components of vector A. Now, in and of itself, I look at that and I say, I'm not really sure what to do with those. But if I think back to the start of when I explained vectors, I realize that I'm allowed to slide these vectors around and rearrange them any way I'd like. So what I'm going to do is I'm going to rearrange the vectors so they look like this. This is my AX. This is my AY. I tried as best as possible to make sure I didn't change the vectors at all. I didn't want to change the length of either vector. I didn't want to change the direction of either vector. And then this would be my A vector all by itself. So there's A, AX and AY lined up. What you'll notice here, by the way, is that AX plus AY, I said plus because I lined them up head to tail. I put the tail of AY at the head of AX. So when I line up AX and AY head to tail, when I add them, I get A. That makes sense with everything I said. These are not their own separate vectors, they're just a piece of A. So it makes a lot of sense to me that AX plus AY would just give me the A vector all by itself. So anyway, I rearranged them in this nice little triangle here. I know that the angle in this triangle is 30 degrees. And don't forget, I also know the magnitude of A is 5. And so what I'm able to do here is split A apart mathematically into its horizontal and vertical components using a little bit of trigonometry. So you're going to need your calculator out. You're going to need it in degrees mode. If you try to do these problems in radians mode, you're going to get them wrong. There's no way around it. So here we go. If I want to find AX, I'm looking at that. I'm saying that seems like the adjacent side of my triangle. If I'm going to find AY, eventually I'm thinking that's the opposite side of my triangle. It's not touching the angle. This is obviously my hypotenuse, the vector itself, vector A. And so now using my trig, I'm going to start with AX. And to find AX, I'm going to use cosine. Because the cosine of theta is adjacent over hypotenuse. So I should be able to use this to find AX because it is the adjacent side. I'm going to plug in the vector names or the vector symbols in here. So instead of adjacent, I'm going to write that as AX. Instead of hypotenuse, I'm going to write A. And if you're in my class, you should know that I like to only plug in numbers at the very end. So I'm going to rearrange this. I'm going to say A cosine theta equals AX. And so then I should be able to actually get a number here. 5 cosine 30 degrees. Again, assuming your calculator's in degrees mode, not radians mode. Assuming your calculator's in degrees mode, you should get 4.33. And so AX has a magnitude of 4.33. So now we know vector A all by itself has a magnitude of 5. AX has a magnitude of 4.33. All right, I'm going to do the same type of thing, but this time solve for AY. And so I'm not going to be able to use cosine. This time I have to use sine. So sine of theta is opposite over hypotenuse. That should help me find AY. Once again, I'm going to plug in my vector symbols rather than having opposite and hypotenuse. So that's going to be AY over A. And then just like before, I'm going to rearrange it without plugging in any numbers. And then the last step is to plug in numbers and use your calculator in degrees mode. If you plug that into your calculator, you should get 2.5. And so now we know AY is 2.5. So we have the magnitude of AY, we have the magnitude of AX, and we still have the magnitude of A with its angle. So that's splitting one vector up into its horizontal and vertical components. It seems kind of pointless right now, but in the very near future you'll see how useful that can be when you're solving problems.